Good morning, everyone. Last time we were discussing chapter 10, which was hypothesis testing for two samples. Um, uh, we were discussed till example 5. And what we were going to do, we have to define, first of all, the 5 steps we are going to do. One thing is, first you have to define null hypothesis, which is associated with the equality, and you can find it out in your, and I told you that how you can figure it out from your question. And the alternating hypothesis is something that is is a claim, a kind of claim that is given in your question, or opposite to the claim that is given in your question. For example, that the average height of group A is equal to the average height of group B. So that is our claim. Then we can tell that we can say that this is our null hypothesis. And opposite to that statement is equal to, there is no difference between these two groups, the average height of these two groups. Then you can say that it is not equal to, or something more or less will be given in your question. And then we have to decide that which test we are going to use. There are 4 tests that we will be discussing in chapter 10 for two samples. One is two sample Z test, when both population standard deviation is known to us. And the second one is that two sample T test, where one sample population standard deviation is given for one group, and we do not know any information about the population standard deviation for the other group, but we have any one of the sample standard deviation is given, or for both groups we have sample standard deviations. Then we can use t-test. The z-test we can use for two samples only in that case when we know about population standard deviations for both groups. Then we can use z-test. The third one is associated for the proportion. Then we can use proportional test for the third one. And there is one test we will be discussing in this chapter, which is for pair data test, that we will be discussing soon in one of the examples. So let's have a look. Example 6. Example 6 says the healthcare worker wishes to see if the average number of family daycare homes is greater than the average number of daycare centers per county. So the claim is for the healthcare worker that he wants to see if we have two groups. One is family daycare homes, and the other one is daycare centers in a county. So the number of centers for a selected number of counties is shown in the following table. We have a raw data in this case. We do not have the information written, such as sample standard deviation is this one, the sample mean is this one. It's not like this that we have been given in the question, but we have the raw test, and we know how to deal with the raw test in our calculator. You will edit the list in your calculator. So first of all, we will see that how we can look for the null hypothesis and the alternating hypothesis testing. Alternating hypothesis we can define. Well, we have these two groups. So first group is, we have a group 1. You have to be uh, very careful when you are selecting one group or another group, because if you are calling one group, as like in this case I'm calling um, the family daycare homes as a first group, and group 2 I'm calling daycare centers. So this is my first group. Second group. So it means when I will be discussing, when will be saying like mu1, which is the population mean for the first group, then mu1 is associated to the daycare homes, and mu2 is associated to the daycare centers. So you cannot switch with each other. If you have defined your, once you have defined your groups, then you have to write down the population mean or sample standard deviations accordingly as you have written in your solution. So now we have to define null hypothesis. So null hypothesis, what is the claim? That he wants to see that the average number of daycare homes is greater than the average number of daycare centers per county. So the word greater is given to us. So it means because my null hypothesis is associated with the equality sign, otherwise our test will not work. So I'm going to say that the average daycare homes, number of daycare homes is equal to the average number of daycare centers, because equality sign is associated with our null hypothesis. No matter what the claim is, always you will put equality sign with the null hypothesis. So alternating hypothesis, now alternating hypothesis will be our claim that is given in my question, because healthcare worker wants to see that if the average number of family daycare homes, which is my group 1, is greater than the average number of daycare centers per county. So this is my second group. So now I can write my claim is in alternating hypothesis, mu1 is greater than mu2. Now, which test we are going to use? Because this is our raw test, we do not have any information for the population standard deviation. So we will be using t-test, two sample t-test in this case. Now I have to look for the value of p. First of all, you have to write down your list, because this is your raw data. So press stat, go to edit, and then you have to write down all your list 1 and list 2. In your list 1, I'm writing down the daycare homes, number of family daycare homes, which is 25, 56, 34, 42, 21, 44. And L2, list 2 is number of daycare centers, which is 16, 14, 5, 28, 37, 48, 20, and 22. So the rest I will delete. So you have to make sure that your L1 is the number of family daycare homes and L2 is your number of family daycare centers, because mu1 will be associated to my list 1 and mu2 will be associated to my list 2. So this has to be written consecutively in the following order. So now you will again press stat once you write down your values, then go to test, stat, press stat, and then go to test. So the number 4 is your two sample t-test. I'm going to select this. And again, you will go to data. It's already on data, not on stat, because stat you will use when you do not have a raw data and you have the information about these two groups. So we will be using raw data. This is why I'm going to use the lists. So data values will be using over here. So you can see that my mu1, list 1 is L1, list 2 is L2, and frequency you will be using 1, 1 on both of these things. And then mu1, so the next one is because my alternating hypothesis is mu1 is greater than mu2. So I'm going to select this one. So once you select this, then next you will be using pool, which is yes or no. So throughout we will be using unpooled data. So both standard deviation is not the same. So pooled is not pooled. And then you will have to calculate. Once you calculate, my p-value is given to me, which is 0.0456. So what is your alpha in this case? So I think I missed the value of alpha over here. Somehow here I missed the value of alpha. So I'm sorry, I need to correct it. Let me see what is the value of alpha. Sorry, I missed the value of alpha before. So alpha is 0.01 in your question, which I missed it. So you can correct it, which is in example 6, at alpha equals to 0.01. Can it be concluded that the average number of family daycare homes is greater than the average number of daycare centers? So alpha is 0.01. So as per this value, p value is greater than, so in this case, my p-value is greater than alpha. So what is my conclusion? If my p-value is greater than alpha, it means we do not reject null hypothesis. So if we do not reject null hypothesis, so what does it mean? So the word close is very important over here, that it means that the average number of daycare homes is close to the average number of daycare centers. This is my interpretation. So the average number of daycare homes is close to the average number of daycare centers. So this is my interpretation. Next example is, so now we are, let's see what is example 7 is. It says, as an aid for improving students' study habits, 9 students were randomly selected for the survey to attend a seminar on the importance of educational life. The given table shows the number of hours each student studied per week before and after the seminar. At alpha equals to 0.10, did attending the seminar increase the number of hours the students studied per week? So now we are in our fourth type. It's not Z-test, T-test, or the proportion, but we are in a pair data test. So what it is, that we have some group. What do we do? That we have do some kind of experiment on that group. First, we have readings before some kind of experiment, and then I have some reading after the experiment for on the following data. Like in this data, we selected 9 students for the survey, and we gave them a seminar for the importance of educational study. So we are going to see that how much does it going to affect on them, that would it be helpful for the students or not. So this is why we have one data before the seminar and one is after the seminar. So these are the values in hours, the study hours is given into you, like in 9 students, like first student before previously he was studying 9 hours, and after the seminar he was studying 9 hours. So there is no effect on the student even after the seminar. So the second student, which is here, the 12, were studying 12 hours before the seminar. So once he had a seminar on, once he attended the seminar on the importance of educational life, then he thought that, okay, this is useful, I have to study more. Then he studied more hours. So he studied 17. So it means he increased his number of study hours. So this is how we are writing all the values of number of hours for the studies per week for each student. So in this case, now we have to check that what is the difference, how it has been affecting on them, the seminar, how useful it is for the seminar. So let me see, now we have to calculate the difference in it. So I'm going to create one more raw column or raw information row, which is for the difference for number of hours for each student. So for the first student, there is no fact 9 minus 9. So in this case, how I'm going to write it down, we will take the difference. So difference is after and before. So after minus before, then you can see that how much change it is going to happen after the seminar. So second student is studying more. So it means 17 minus 12. So this is 5. Third student was previously studying 6 hours, and after that he was studying 9 hours. So 9 minus 6 is, it means, which is 3 hours. He increased his number of study hours. Fourth student is 5. Fifth student decreased his number of study hours. So because previously he was studying 3 and then he studied 2 hours. So it means he decreased, his performance was bad. So it means this is -1. He decreased his hours. So the next student, 21 minus 18, which is 3. And the next student is 5, positive 5. And here the difference you have to be very careful in writing the difference, because this negative and positive is very uh, very vital to change the value on your results. So this is how you have to write down the difference of the values, like after minus before. So the next student, 22 minus 13, so he increased his number of hours, which is 9 in this case. The last student decreases number of hours. So I am going to see that after so did the number of hours increase after the seminars or decreased? So this is my hypothesis. So this is, going to call, we are going to use one sample hypothesis testing, because we do not have two samples, just one sample, and we are going to change the average of the differences. We are going to look for that. Does it going to change or does it going to improve? So my null hypothesis is I'm going to call this difference as uh, small d, let's say. So as we can see in this difference row, that all the values are positive, most probably they are positive. So I'm going to say, let's say that the average for the differences, average of the differences for the study hours is equal to 0. There is no change in their number of study hours. So this is because my null hypothesis is associated with the equality sign. So I am going to say, let's say all are positive. So I am going to assign it with 0, that there is no change in that. And null, and my alternating hypothesis, because all values, most of the values are positive, they increase their number of hours, except two students who have decreased their number of study hours. So I am going to write it down. Let's say the average of the differences for the study hours increase. This is my claim. So because this is the claim we have been seeing over here, that did the attending seminar increase the number of hours? So this is my claim, it is. And we are going to see with the following differences, because most of the differences are positive in this case. So average of the differences is positive in this case. So this is how I'm writing my null hypothesis and alternating hypothesis. Now, which test I'm going to use, because we have only one raw data, which is the difference for the study hours before and after. So this is my one sample t-test. I'm not going to use z-test because I do not have any information for the population standard deviation, like population average differences. We have just limited number of students. So now, because of this raw data, we have only sample standard deviation. We can find it out by using the calculator in this case. So which test I'm going to use, which is one sample t-test. Now I am interested to find the value of p. So what you have to do on your calculator, press stat, again go to edit, and on your list one, you will, because previously I have already a data, so only I'm going to change L1. L1 will be this number of differences for the study hours. I'm going to write it down, which is 0, 5, 3, 5, -1. So anyway, so this is how I'm going to write it down, and then I'm going to stat and test one sample. Second one is for the t-test. Second one is t-test. So I'm going to write down t-test. And again, you will go to data. Mu naught here, you will going to change it with 0 because mu naught, which is your null hypothesis, that I'm going to say that there is no change for the number of study years, which is equal to 0. Like I'm writing down like this. So this is my L1 list. Frequency is 1, you always write down. And alternating hypothesis is greater than mu naught, which is already selected. And then you have to press calculate. So now your p-value is 0.0116. So what was the alpha? Alpha was given 0.10 in your question. So this value of p is less than alpha because alpha is 0.10. So if this is less than alpha, so what is my conclusion? Conclusion is that we are rejecting null hypothesis. So if you are rejecting null hypothesis, so it means alternatively you are going to accept the alternating hypothesis. So what is your interpretation? What is the interpretation for the for the alternating hypothesis? That on average there was an increase in time spent or time for the studying spent by the students. So that on average there was an increase in time spent studying after the seminar. So this is my interpretation. The next one is the same again, paired data we are going to use. Next example is a study was conducted to investigate the effectiveness of hypnotism in reducing pain. So what they are going to do, they are going to study on some patients. They give them some hypnotism. They are going to see whether their pain is decreased or increased. So what are the results they are going to see? So results for randomly selected subjects are shown in the following table. A lower score indicates less pain. The differences are normally distributed. Are the sensory measurements on average lower after hypnotism? On average, lower after hypnotism. It means this is the question for the average mean, and lower means that it is going to reduce or increase, what we are going to see. So test at a 5% significance level. So that means 0.05. You are going to alpha is my 0.05 in this case. So you have to look at for this thing. So previously the pain rate, again, I'm going to check the difference for these values. So let's see. So how you will check this rate, that after minus before. This is how you will check the difference. So 6.8 minus 6.6, which is 0.2 in the first one. B1 is minus 4.1, the difference, because 2.4 minus 6.5. And again, the third one is minus 1.6. Fourth one is minus 1.8. 8.1 minus 11.3, which is minus 3.2, the difference. So you are going to see that the pain is going to reduce after hypnotism. The next one is minus 2. Next one is minus 2.9. The next one is minus 9.6. So this is how we will check the difference. So you can see here that most of the values are negative. So it means we can say that the pain is going to reduce after hypnotism, but we have to check it by using the hypothesis testing. So what is my null hypothesis? That the average difference for the pain decrease, there is no difference for the average pain, let's say, because this is my null hypothesis is associated with the equality. So alternating hypothesis is that on average, the pain rate is going to reduce. So it means less than 0. And then You have to use test because this is one sample. We are going to discuss the pair data for one sample. So this is one sample t-test again. And now I am interested in the value of p. So again, you will write down all the values in your go to edit, press stat, edit, and on your list one, write down all the values for the differences, these differences, 0.2, minus 4.1, these all these values. So once you write it down, once you write it down, then you will again press stat, go to test, and then you will go to t-test because one sample test. This is my, no need to write one sample because this is just t-test. So t-test means one sample t-test. So now I'm going to see the value of p is 0.0095. So my alpha is 0.05. So it means p value is less than alpha. So what is my conclusion? If p is less than alpha, so that means we are rejecting null hypothesis or reject null hypothesis. So if you are going to reject null hypothesis, so it means alternatively you are going to accept the alternating hypothesis. So this is my interpretation for the test, that on average, the pain score decreased after hypnotism. On average, the pain score decreased after hypnotism. There is a next example. Let's see what it says. In 2017, a sample of 357 males from the boomers generation showed that 75 had been veterans. A sample of 700 males from the millennials generation showed that 28 had been veterans. Is there a significant difference in the proportions? Use alpha is 0.05. Again, now we are talking about the proportion. Now we are in the proportional test, two sample proportional test. So two prop Z test we are going to use in this case. So first you have to decide which is group one, which one is group one and which one is group two. So we have two groups, which is one for boomers generation and another for millennials generation. So I'm going to call group one is boomers generation and group two is millennials generation. So it means if I'm talking about the prop one, which is proportion for, it means proportion for the boomers generation, and prop two I will be using for the proportion for millennials generation. So we are going to check significant difference. So first I'm going to see the null hypothesis. So I'm going to say that prop one for the boomers generation who were found that the 75 was veteran for the boomer generation is equal to the proportion for the millennials generation. And alternating hypothesis is your claim that is there a significant difference? So I'm going to say there is no difference. So prop one is not equal to prop two because there is nothing written that proportional for the first group is greater than proportional for the second group or something like that, less than. There is nothing like that is written. If this is written, then we will write it down as an alternating hypothesis. So it says that is there a significant difference? So I am going to say there is no significant, there is no difference between them. So They are different from each other. So I'm going to write it down as an alternating hypothesis. So which test we are going to use, which is two prop, because we have two groups. Two prop Z test we are going to use. Next, I have to write down the value of P that we will be finding out from our calculator. So again, go to stat, test. So the number 6 is your two prop Z test. Then you will select this. Here you can see X1, N1, X2, N2. So X1 is my the how many were veterans, 75, and one is the total number of males in boomers generation, which is 357. This is how you will be writing it down. So X1 is my, because one group I'm going to tell for the boomers and the second group for the millennials. So everything in X1 and 1, the values will be for boomers, and X2 and 2 values will be for millennials group. So X1 is how many people were veterans? 75. And one, how many number of males they were selected, which is 357. X2 is for the millennials group, how many were veterans, which is 28. And two, how many number of males they were selected, which is N2. And P1 is not equal to P2. This is how I will be writing it down on my calculator, all the values. So once you press calculate, it will be giving you the value of P is 1.18, and it is in scientific notation. So I'm going to write it up to 2 decimal places, 1.18 times 10 raised to the power minus 18. So 1.18 times 10 raised to the power minus 18. So it means value is very small, that it is kind of negligible. So P value is less than alpha because my alpha is 0.05. So this is very less value. P is less than alpha. So if P is less than alpha, what is my conclusion? That we reject null hypothesis. So in interpretation, what I'm going to write down, that the proportion of boomers who were veterans is not equal to the proportion of millennials who were veterans. So the proportion of boomers who were veterans is, because we are rejecting null hypothesis, so alternatively I am going to accept my alternative hypothesis in terms of writing. So is not equal to proportion of millennials who were veterans. That's it. This was my example 9. In example 10, again, this is for proportions. Let's see what it says. Pew Research did a survey in 2018 looking at the numbers of parents who are solo parents, meaning raising their children alone. Among a sample of 644 solo fathers, 161 were classified as being white. Among a sample of 763 solo mothers, 183 were selected as being white. So we have two groups. One is for with single parent, they raise their kids, one for fathers, the group for fathers, and second group for mothers who raise their kids alone. Is there a significant difference in the proportions of each group which was classified as being white? So use your alpha is 0.10. So what is my group 1 in this case? For fathers, single parent, and group 2 for mothers as single parents. My null hypothesis is that my null hypothesis is the proportion, that there is a significant difference for the proportion in each of these two groups that were classified as being white. So let's say we are going to say that there is no difference for both of these proportions. So let's see, prop 1 is equal to prop 2. Why I'm going to write it down prop, why I'm not calling it as P, because P we already are using as a P value. So I'm not going to make a confusion with the prop value and with the P value. This is why I'm going to write it down prop as a proportion as a prop. So H1 is alternating hypothesis. Let's say these two proportions are different from each other being a single parent. Sorry, this is 1. Which test we are going to use? 2 prop Z test. So now I have to find the value of P. Again, go to stat, test, press 6 to prop Z test. X1 and 1 is associated with fathers group. So how many fathers were selected for the sample who were classified as white? 161 from 644 solo fathers were white, and N1 is 644 total number of fathers. X2 is the number of mothers who were selected as white from among 763, which is 183. N2 is 763. And P1 is not equal to P2 as an alternating hypothesis. This is my data. I'm going to write it down like this. And now I have to press calculate. So now my P value is, in this case, P value is 0.6587. So what is my alpha? Alpha is 0.10. So alpha is 0.10. So this means P value is greater than alpha. So if P value is greater than alpha, so that means, what is my conclusion? Conclusion says that we do not reject null hypothesis. So what is my interpretation? Interpretation says that the proportion for the solo parents from fathers being white is, who were classified being white, is close to the proportion for the solo parents for white people, for white mothers who were selected as white mothers. So the proportion for the proportion of solo fathers being white is close to the proportion of solo mothers being white. So the word close to is important, is being white. Being white. That's it. Example 11 says, in a sample of 800 US adults, 44% said they trusted people from holistic or alternative health groups when talking about vaccines. In the same sample, 49% said they trust pharmaceutical industry leaders when talking about vaccines. At alpha is 0.05, does a lower percentage of US adults trust holistic groups than pharmaceutical leaders when talking about vaccines? So you have to, this is again the proportional data. So you have to check total number of samples we have selected, 800 US from amongst adults. 44% of people trusted that from holistic or alternating health groups when talking about vaccines. And in the same samples of 800 US, 49% said that they trusted pharmaceutical industry leaders. So one group is for pharmaceutical industry leaders and one group for um, that they trusted people from holistic or alternating health groups. So there are two groups we have been discussing, one who were trusted on holistic or alternating health groups and one who were trusted on pharmaceutical industry leaders. So in both cases, your N1 and N2 is 800 because the sample size is same, only the proportion is different. So it means you have to use that how many number of people will be 44%. You have to calculate the 44% of 800, then that will be giving your giving you your X value. It means X1 you can calculate by 44 divided by 100 multiplied by 800. So this will be giving you your X1 value. And X2 value is 49% of 800 US adults who were trusted on pharmaceutical industry. This will be giving you your ad for the group 2, X2 value for the group 2. So then you have to, and your N1 and N2 in both cases will be 800. And after that, you have to find the value of P1, P value. So what you have to do, you will say, but you have to calculate that alpha 0.05 does a lower percentage of US adults trust holistic groups than pharmaceutical leaders. So it means first group we are going to associate it with the holistic who trust on holistic groups and other group who trust on pharmaceutical industry. So it says that holistic groups is less than the pharmaceutical leaders. So it means people who trust on holistic groups is less than, it means prop 1 is less than prop 2 you have to write down. So then you have to calculate the value of P after that. Let me do it for you. So which is group 1, people who trust on holistic groups, and group 2, people who trust on pharmaceutical industry leaders. Pharmaceutical industry leaders. So this is how we are writing it down. So null hypothesis, let's say prop 1 is equal to prop 2. Like people who trust on holistic, they both trust on those both two groups equally. And H1, which is your alternating hypothesis, that does lower percentage of US adults trust on on holistic groups then. So it means people who trust on holistic groups, prop 1, less than people who trust on pharmaceutical leaders, is which is prop 2. So this is how you're writing it down, your alternating hypothesis, which is your claim in your statement. So then you have to write down the test, which is 2 prop Z test. And I told you how you have to write down the values of X1 and N1. X1, X2, and N1, N2, N2. N1, N2 is the same, which is 800. Then you have to find the value of P. So again, I'm writing it down over here. X1, which is associated for holistic group. So 44% of people trust on that. So 44 divided by 100 out of 800 US people, from the sample. So this is how, so 44 times 8. So this means 352 people out of 800 trust on holistic group. And X2, how many percentage trust on pharmaceutical industry, which is 49%. So 49 by 100 multiplied by 800. So now So it means 392 people out of 800 trust on pharmaceutical groups. So this is how, and N1 and N2 is the same, which is 800 for both cases. So these values you have to write down on your calculator. Go to test 2 prop z test. X1 is 352 and 1 is 800. X2 is 392 and 2 is 800. And then I am going to select P1 is less than P2. So this is how I'm going to write down all the values in my calculator. Then you have to go to press calculate. So P value is 0.02249. So what is alpha in your question? 0.05. So alpha is 0.05. So P value is less than alpha. So conclusion is that we are rejecting null hypothesis. So it means alternatively, we are going to accept our claim, which is alternating hypothesis, that the proportion of the US adults who trust on holistic groups less than the proportion of the US adults who trust on pharmaceutical leaders. So this is how you have to write it down. Interpretation. The proportion of US adults who trust on holistic groups is less than the proportion of US adults who trust on pharmaceutical leaders. This is how you will be writing your interpretation. And this is end of chapter 10. Now we will be starting chapter 12.